Hi everyone. So before we begin, I want to talk about what this video is going to be about. This video is and who is it for? This video is going to be about building the fundamentals which you can use to excel in AI world, and we'll start from the basic. We'll try to question everything with why why something works, why something is done in a certain way. And to do that, we'll be also reinventing the wheel against the common accepted philosophy of not doing that. We'll be starting from scratch, and then we'll build up those fundamentals of mathematics. And a lot of people generally give up thinking the maths behind machine learning and AI is very complex, but I will try to make it as simple as possible to make it intuitive, and so you can also basically think how to visualize things, why things work in certain way, and to do. And who is it for? This is for any, this video series is going for anyone who has basic idea, just even basic idea about maths or physics or computer science. Or even if you don't have any idea, trust me, I will be able to, I think I'll be able to explain things in a way where everyone can learn from it and can understand in the end how AI works, all those big complex transformers. But we'll start from fundamentals. Now, let's begin. Before we dive into all ML concepts, I want to talk about something called semiotics. So, what is semiotics? Semiotics is basically the science, study of signs and symbols and their use or interpretation. Why I'm talking about this? Because, see, again, machine learning is in context of current AI advancement. The large language models basically understands human language, but and reciprocates in that same manner. Like if you ask it a question in plain English, it returns you the answer in the plain English. And for now, you can call it intelligence, but that's a totally different topic. What is intelligence, what is life, and all that. But so semiotics is basically a science of symbols. Why symbols and why science? We are talking about these things because ultimately all the human knowledge that we have acquired so far has been translated in some time in some type of signals. And these signals, when written, they are basically signs. Now, in semiotics is science of that. So there are two major things. One is signifier and another is signified. So think of it like this. I just googled it. So this is a very good example where this is an icon of a tree. When you look at this icon, the signifier, the physical form, the letters, icons, and the song, so this basically represents something. When I ask you what it represents, any baby or adult or anyone, a human being can tell it represents a tree. So the mental concept is a real life tree. Now, once you have understood this, you can think any, even when I'm talking to you, the words which I'm speaking, all of these words have a specific meaning attached to it, and these meanings are in the absolute uh, meta sense, doesn't have any relation with the meaning it is attached to, but it is on a social agreed rule book. You can say that this basically means yellow, or phone means this, a notebook means this. So like that, you have to basically uh, you can start thinking that words or numbers 1 2 3 4 basically represents something. So whenever we are talking in terms of language or science of anything, we are using symbols. And there's a beautiful part of mathematics which is called category theory. If anyone is interested and wants to go deeper, they can learn about category theory, which is like a maths of maths. But if you are not yeah, so category theory is another thing, that's a side topic, we'll get into that later. Now let's go back in time when the civilization was in a very early stage, or not even civilization, like when we were cavemen. We started drawing visuals on the caves, and it used to represent something, right? Now think of a society, a civilization where trade has started happening. Now think of these three symbols. People used to draw these three symbols, and let's say they represented something called diamonds. And the other party which used this circus to represent, let's say, a bowl of rice. Now these two, when they are given, so for two bowl of rice they need to exchange three diamonds. Now party A and party B started representing these things. So this is more like, think of it as like auditing. So auditing started happening. Now people realized that if I represent these and these again and again, they understood that these quantities are like a property. We need not have to represent all of these different symbols. So goats are there, let's say cows are there, milk is there. So for all of these you will draw different symbols. But later people realized that the quantity itself is like a property. So for example, this 3 is a property. These represent 2. These represent 3 quantities. So we came up with the new symbols, and these symbols were like this, where 1 represents something of one quantity, and similarly 2 quantity, 3 quantity, and this quantity has some units. Let's say we don't know the unit. Now once we have developed these numbers, and by the way, you can also think of other civilization, like Romans had their own symbols to represent, like say, I think this is 1, this is 2, 3, 4, 5, like that. So now these symbols are representing a quantity, right? Cool. So far we have understood that numbers started developing and they came into the picture, right? Cool. So this is by the way a GitHub repo that I have created. I'll be including all the details, whatever I'm teaching here, all of those things will be included in here. Cool. So semiotics, we talked about this. Numbers are a way to measure unit. Now take a second, take a minute and think all the things that we use in our day-to-day life. We use numbers to represent them. A lot of things. It could be like, how many plugs do you need, how many bulbs do you need in a room, how many fans do you need. We are using, we came up with a language. Maths is a language. So math is also a language to represent the physical world which we see and observe. And coming back to the numbers, once we started understanding that these are the numbers which represents the quantity or the unit, we started thinking, okay, cool, we have numbers, but human brain is capable of learning things in visual manner. So we basically what we do is we try to learn things visually. Our brain, our cortex is very good in understanding in that way. So what happens is we come up with something called a number line. And how did we do that? We drew a line and we said, okay, this will represent, let's say, here we'll have 0, and similarly we'll have 1, we'll have 2, we'll have 3, and similarly. Yeah, let's say we have not yet developed the sense of negative, just assuming we are on the timeline where we have 0 till infinity. Now the numbers which are 1 to infinity, these are known as natural numbers. From 0 we call it whole numbers. These are basically, I'm still just talking about integers, nothing in between. Now whole numbers are there, natural numbers are there. Then we also have real numbers. And one thing that I want to understand, I want you all to understand, is that take this question like between 0 and 1, how many numbers exist? Think and take like decimals, fractions, all of that. If you take into that account, if you take those numbers into account, I guess you all have said it correctly, it's infinite. So the numbers that exist between 0 to 1 is a set of infinite numbers. Okay. How many numbers exist between 1 to 2? Infinite. How many numbers exist between 0 to infinity? That is also infinite. But one thing that I always find fascinating is, can I say that the numbers 0 to infinity is bigger than the infinite numbers between 0 to 1 or 1 to 2? Take a pause of 5 seconds and tell me. By the way, why we are investing so much time in numbers? Because numbers are the core building blocks of physics, of computer science, and all the data structure algorithms, physics symbols, everything which you learn. Or I would even argue that our whole knowledge base is based on symbols and numbers. Cool. So the answer to that question is, all of these infinities are same. And if you ask me like how is that possible, like think about this. I took a lot of time in grasping this concept and really understanding how numbers are so tricky. And when we learn about linear non-linear transformations, these concepts will help you a lot. How, because these are very non-intuitive things, but the moment you understand these things, a lot of things make sense and become obvious. Cool. So I would say okay, uh, I don't want to move forward in the concept, but okay, let me just give it a try. So for example, if I give you a number between 1 to 2, let's say you take all the numbers between 1 to 2. So your input is everything between 0 to 1. I don't want to get into this. Let's do it later. I will explain it. Like, this is related to the mapping. I don't want to get into the mapping concept right away. Okay, cool. So far we have understood there are a lot of numbers, and we created a number line where we represent all these numbers. Now once we have a number line, let's get into the next concept. So we have now invented number system. When I say number system, and people who really want to understand these concepts, I would like you to just think about numbers for like 10-15 minutes whenever you get time. Just imagine yourself sitting on a number line, and you can see on the right side 0, 1, 2, 3, 4 till infinity. Similarly on the left hand side where you have -1, -2 till minus infinity. Cool. Now that we have numbers, let's uh, let's think about how uh, the numbers occur in our day-to-day life, because ultimately we created these numbers to represent our physical things, right? Now if I'll ask you, uh, what is the temperature, or how's what is the temperature now of the room where you are sitting? So you might use a thermometer or something like that, and you will just I don't think, yeah, thermometer will also work. So you'll use a thermometer to measure temperature, and let's say you started recording those numbers, right? I asked you now, I asked you 1 second later, another 1 second later. So, or let's say with an interval of 1 hour. So throughout the day, in 24 hours, you have 24 readings of the temperature of your room. All of these numbers you can write down as a simple table. Okay, right? Let's say 17 degree Celsius, 15 degree, 15 degrees Celsius, 16 degrees, 16.5, 20, 30, 40. All of these readings are there. So far we have developed numbers. Now, when we have set of these numbers, there must be some information hidden that we need to extract from it, or some things which can give me a better idea about how is the temperature overall. Now, what we can do is, let's say you don't know any mathematics, and uh, I ask you, these are 24 readings, and tell me how was the temperature, and you have to give me just one number. What did you do? You, as the first person who is the in charge of inventing mathematics in the world, you would come up with an idea of adding these numbers and then dividing them with the quantity, which is like mean. Cool. But there's a problem with that. When we add the numbers, some information might get lost. For example, we have two different days where on an average we got 17 degrees Celsius, 17 degree on day 1 and day 2. But the variations of the temperature was quite different. Uh, for example, let's say you are in very cold region. In the morning the temperature goes till, let's say, 20 degrees Celsius, but in the night it goes up to -18 degrees Celsius. Whereas when you are in tropical region and you are measuring the temperature, there also you might get an average of like 20 degrees Celsius, 21, 22. But to understand the hidden meaning or hidden data or hidden information behind those data points, you will come up with something which can measure the spread or distribution of these from the mean position. So this is where you develop something called a variance, where you subtract the mean from individual temperatures, squares them, and then add them, and then divide with the total numbers. So that is what variance is. Cool. So congratulations, now that you have developed numbers, and now you have given the world statistics. So these are the two major things we develop today. Okay, cool. But we also realized that these numbers are not actually occurring in a single unit. What do I mean by single unit? So it could be a combination of two things. For example, if you want to measure something called yeah, let's say temperature and the color. Cool. So when I ask you to measure two different attributes of a hot rod iron, and what you will do, you will, let's say, measure 1800 degrees Celsius orange color, 1500 degrees Celsius dark brown, 1000 degrees Celsius some other color, and you will keep going down, and let's say at the room temperature it will be something like silvery grayish. So all of these things are now occurring in tuple. What is tuple? When you are measuring two things at the same time. So I'll just draw what we did so far. We came up with an idea of number system where temperatures were occurring 17 degrees Celsius, 18 degrees Celsius, 20 degrees Celsius, 40, 50 degrees Celsius, minus 10 degrees Celsius till, let's say, 3 to 5, and then 19 more entries. Cool. So these are the temperature readings. But we also realized that in the real world, things can occur in pair, which could be like temperature and color. At 1700 degrees Celsius, it was dark brown. Okay, so this is one number. Similarly, 1850 degrees Celsius, it was hot red. I might be a little off with the science behind things, but yeah. So similarly, yeah. So all of these entries will be made. Now, we had number lines, and let's say instead of, yeah, cool. What we can do now is, you can also think of as, okay, one thing represents temperature, another thing represents color, and they are occurring in pair. So these and these, these and these and these, like that. The mappings are there. People started doing this, and it was fine. Someone came and said, hey, instead of doing like this, how about I create one axis like this and another axis like this. This axis will represent my temperature, and this axis, let's say, represents my color. And then you can plot these temperatures and colors, like here, some negative temperature also. Cool. And by the way, yeah, so this will represent some color, this will represent some color, this will represent some color. Similarly, this will represent some temperature. This is another temperature, this is another temperature. Cool. So far we have developed a coordinate system. Or if you don't want to do and go into coordinate system, let's just think of things in terms of numbers only. So dark brown, hot rod, all of these things are number only. Cool. Think of another scenario where you have something where things are occurring in three sets, where you are measuring things like quantity A, quantity B, and quantity C. So all of these are now, we can call it as R1, where all of these entries are coming in real numbers. What R2 will represent that it is a tuple of 2. Similarly, R3 and so on and so on will have R of NM. No, I have not used the word dimension yet. Forget that you heard it. Cool. So far we have R1, R2, R3 and Rn. Now we have numbers, and with those numbers we came up with some kind of mathematics around it, which can give me more information, or a short form of understanding the information, which was statistics. Then we plotted those number lines, and then we started seeing a combination of these observations, and we came up with R1, R2, R3, Rn. Cool. So far we have developed these things here. Now in the real world we have things where I would say the things are, yeah, let's go back to semiotics. In semiotics we had signifier and signifier, what it represented, what the mental picture was. Now think of a system where an observation is being made on something, but we know there is an underlying variable. And what could be that? So for example, if it could be anything, you can think, I wouldn't ask you to think only in numbers. You can think of anything, like when you are happy, you smile. When you buy 2 kilo of potatoes, you pay X amount. If you run the motor pump for 10 hours, you get 600 liters of water in the tank. If you walk for 100 kilometers, you burn this much calories. And these are one-to-one mapping. So we started observing these things where number A was being related to number B. Okay. Okay, cool. Now note, what I am talking about here is the mapping, where one set of things I'm calling as input and another thing I'm calling as output. So these mappings are what known as functions, and these functions are common in mathematics as well as computer science. Okay, and you can also think of it as like a juice machine, I would say. Like you put in the fruit, run it, you get something out in the liquid form which you drink. So mapping and the functions are something which maps a set of numbers to another set of numbers. And why I'm talking only about numbers, we will expand our concepts to all different parts when we'll go to LLMs and all, but so far we're restricting ourselves to just think in terms of numbers. So numbers have mapping from one system to another system. Okay, and this is again the same concept where this plotting were done. Here all of these were just observations, and here we are talking in terms of mapping. Now that we had the number system, note this mapping can also be visualized in XY coordinate. Where is that free drawing tool? Is it? Oh yeah, cool. So this is just an observation of numbers. So this is 1, 2. Oh wow, look at this. uh, notation, music notation. Anyway, yeah. So these are the points: 1 point, 2 point, 3 point, 4, 5, 6. Let's say 7. So these are numbers which you had, where this is your output and this is your input. Generally we call it X and Y. Why these things are important? Note, we started with numbers, we came up with this function mapping, and then we came up with a way of visualizing these things. Now if I'll ask you what is okay, yeah, so now let's discuss about domain and range. These are two things which we will use. So domain basically talks about what is the range, what from what value to what value your input space spans. Okay, range is for output. Okay, so let's say we had observations from -5 to -5 to +10, let's say, and the output ranged from, let's say, 0 to 150. So we have a domain of -5 to 10 and range from 0 to 150. Cool. So far everything is good. We have understood numbers, we understood how we as a human started representing everything in numbers, and then we came up with the number line, and then we started plotting things to see and visually understand things better. Note, we'll dig deeper into the information theory later, which is given by Claude Shannon, but when we are representing things like this versus things like this versus just a list of numbers, we are nowhere creating new information. These are just a way of representing the same data in different formats. Why we prefer this? Because our brain is not smart enough to understand these, or to understand the numbers directly and to see the relationship, because we didn't evolve like that. Tomorrow an alien might come who would prefer something like this or something like this, and they might not be okay with this. So why I am explicitly emphasizing on these point, because the machine learning and the whole learning part, and and how computers learn and how we learn are very different, even though we are trying to mimic the neurons and new basically in deep in artificial neural network we are mimicking the brain structure only. But the whole learning, why our approach of learning will be different when we are learning machine learning, is because we are trying to leverage how human brain works, and we will use those information to understand things better. Cool. So far all of these things are with different lenses, and the moment we drew this, we came up with a new mathematics called something like coordinate geometry. I think O is also the coordinate geometry. Okay, coordinate geometry is basically when you draw shit. So far we developed three different types of things: number system, statistics, and coordinate geometry. Perfect. And we also now can think that if these things are on one single number line, they are one dimensional. If they are on two different axes, when you need two different axes, they are 2D. Similarly 3D, 4D, 5D, and dimension. Perfect. Now let's see what it. So visualizing number, we invented the number line, we invented 2D. Cool. Now let's talk about relationship. We talked about functions. What are those? Cool. So far I will wrap it up here. So far we talked about what are numbers. Numbers, ultimately they just represent units. Next we'll deep dive into mappings, where we'll learn about transformations, linear transformation, non-linear transformations, and how we have developed mathematics of solving linear transformations very easily. We'll also talk about matrices, algebras. We'll not talk about, we'll basically invent them. And then we will understand, we'll do some coding. Well, we'll maybe in this chapter 3 we'll do some coding where we'll be writing some linear regression, logistic regressions. We'll expand on that, we'll write some perceptrons, and then we'll talk about something like uh, why nonlinear transformations are required and how the neural networks helps us to achieve that. And a lot of people don't basically skip the concept of universal approximation theorem. We'll deep dive into that, and how the input space is transformed. Basically the neural network is nothing but your input space is transformed in the space and folded into higher dimension in a way where not just higher dimension, nonlinear, I would say, where basically the separations become easier. We'll deep dive into those concepts later, but so far just focus on the numbers. Think about numbers when you go to sleep. Just think about the numbers, and we'll connect again. Thank you.